All right, so you've just learned then that there are essentially two things that are going to determine effect size, right? And one of those first things is how big or how different means are in your study, or alternatively, how strong is the relationship between the variables. All right. So if we see a big difference between the means in a study, then we know that the effect size is likely going to be very large. However, if the difference between the means is fairly small, then we would expect to see a small effect size. Similarly, if we were doing a study and we find a very strong relationship between the variables, then we would say that the effect size is large. And if the relationship among the variables is small, then we would say that the effect size is small. All right, the other thing that determines effect size is how variable scores are in an experiment or study. Right? We use that to calculate the relative effect size. And so these are two things that will influence how large or small your effect size is. So let's go into a little bit more detail about each, and then we'll look at how we're going to manipulate these things in a study so that we can have that win-win-win situation we're looking for. Okay? All right. So the first one, magnitude of the difference between the group means. All right, so we could have a study where the absolute effect size is very small. Now, what would that look like? Well, remember, that would be like the Tylenol and Advil experiment. See, what happens is when you have group means that are very much alike, that is, they're not very different from each other, this will bring HO and HA closer together. All right, so a small difference between your sample means bring these two distributions closer together. And when they're closer together, well, that means they overlap more, right? And so we can see there's a huge area here where we could be making a type 1 and a type 2 error. And if these errors, if this area rather is very large, that's going to make these two areas very small comparatively, right? Okay, so that's what happens if you have two means that are very close together. Again, it brings HO and HA close together. So now you can guess what happens if you test two groups and the means are very different from each other. So that would be like the Tylenol and the Demerol example. All right. So if you've got two group means that are very, very different, that means that HO and HA will be very far apart. And as they move apart, look what happens. They overlap less. And so the shaded in areas where we could be making a mistake, that goes down. So alpha and beta, the two areas combined are very small compared to up here, all right? And then if these areas are very small, then 1 minus beta and 1 minus alpha are very large, okay? So again, just to summarize, if the two means that in your experiment, you're looking at two means, if they're very close together, that brings HO and HA close together. That causes them to overlap to a very large extent. And with increased overlap comes an increased risk of an error and decreases the probability of correctly retaining HO or correctly rejecting HO. But if you've got two means that are very different from each other, that will take HO and HA and move them further apart. All right, so you've got a larger absolute effect size. That will decrease the overlap between the two distributions. And what happens is both errors go down, the probability that is, it goes down for both, and the probability of making correct decisions go up. See how this is a win-win-win? Let's look now at how we're going to actually do this. How do we increase the difference, the spread between means? How do we make them more different? And the answer is use strong manipulations. So what is a strong manipulation? Well, this refers to anything that you can do to your independent variable to increase the probability that you're going to see a large difference between your groups. All right, and so I have this color wheel up here to give you an example of how we might use a strong manipulation to hopefully increase the absolute effect size. All right, so let's say we're interested in studying the effect of color on mood. All right, now again, not being very creative here because those studies have been done upwards, backwards, left, right. There's been a lot of studies on the effect of color on mood, but it fits well with what I'm trying to explain here. So if we wanted to look at the effect of color on mood, we could do this, right? We could compare this yellow to this orangey yellow, right? We could compare these two colors to see if one increases mood more than the other or decreases mood, either way, okay? But this is not a very strong manipulation, and that's because these two colors are fairly similar. If we wanted to increase the likelihood of seeing a difference between our groups, well then compare yellow to blue, let's say, or to purple, or compare green to red, right? Look at colors that are very different from each other, and now you have a greater probability of finding a large effect. All right, you have a greater chance of getting means that are very different from each other, and that will increase the absolute effect size. And what did we learn about that? When you increase the absolute effect size, you spread apart HO and HA, and you decrease the probability of an error and increase the probability of making a correct decision.